Okay, for the final part, people are back from getting their tea and coffee, I guess. We'll dive into it. We'll share the recordings also afterwards. See a thumbs up. Very good. Um, yeah, so we do cover various types of flooding with the modeling system and also the platform. Obviously, flash floods and fluvial floods. We deal with urban details where possible as well, and do coastal and dam break events. I'll show one of those as well. There's a bit of a different workflow typically for how we use it for urban and flash and fluvial flooding. So just to very quickly walk you through that a little bit. For urban setting, it's typically the easiest in a way. You just click anywhere on the map, typically, and select the type of scenario that you want to do. It will take into account automatically sort of the size of the event focuses on pluvial flooding. Then in that scale, by default, it picks a 3.5 by 3.5 kilometer area for you by default as well to run there. So this is sort of the easiest workflow. It does also include then boundary conditions for rivers that are relevant that come into your area to parameterize those automatically as well. Because it's a small area, it's going to use the local extreme precipitation for the simulation that is done. That is a bit different if you select a very large area. So I'll cover that in a bit as well. For flash floods, there's a bit of an option on how you want to do that. Often for flash flooding, you might be inclined to run the catchment where this is either occurred in the past or is predicted to occur. You can select yourself catchments on the website and sort of drag your own model domain there to run. Or alternatively, you can select a catchment. So to quickly show that, on the top right, you have this Add Area button, and then you can select a custom domain. And then you click first on the top left corner and then the bottom right corner of the domain that you want to model. And you can use this to do larger areas if you want. Now, note that for very large areas, we're going to also adjust the extreme precipitation automatically by default. And we do this because if you have a really, really large area, the localized extreme precipitation isn't really a valid event anymore. Instead, you start talking about the movement of a larger system through a river basin. And we have to account for that in terms of how we set up the parameterization of the precipitation input for the event. So the larger the area, typically the lower this gets, and we use our climate statistics to automatically estimate that decrease. And because of that, selecting catchment sort of helps adjust the precipitation also to the right level to be a flood trigger for that particular size of area. Alternatively, if you click right mouse button on the map and say show catchments, you can also select from a global visualization of basins and sub-basins. You can select the area that you would like to model. This is more meant as sort of a guiding a data set for users. So there you can say, look, this is the particular catchment that I'm interested in, or I want to upload my own. You can select those and then model either that catchment or a particular sub-catchment that you're interested in. And you get the same menu, you get the same choices that you might want to make in terms of how you want to parameterize things there. You can, for flash flooding, also turn off this automatic scaling of the precipitation, which can be relevant just to show you a quick example of how that works. I'm gonna run two areas side by side, very similar areas, in fact. This area that had a flash flood event in the Netherlands. And typically what you see with flash flood hazard mapping is that they are interested in applying the local extreme precipitation. But like I said, local extreme precipitation doesn't happen simultaneously over larger areas. That's just very unlikely to happen, especially if you start talking about larger basins. The entire Mississippi Basin is not going to have a flash flood event for every single sub-basin within its entire domain. That's just exceedingly unlikely to happen. So if you still want to do within one computation flash flood scenario for that entire area, there's an alternative approach that's become pretty standard by now, which is to simulate simultaneous local events, but in turn, you supply a certain criteria, a threshold, where if the river is larger than a certain drainage area, we're going to take out all of the water. Basically, we're saying we're only going to simulate then flooding because of these local extreme events, but we're not interested in doing fluvial flooding and accumulation into the larger river system, because that's going to result in unrealistic amounts of flow. Now, by default, we have that disabled, right? So when the user selects any model domain, it is going to do the entire river system. But this is just a quick way to also do sort of the more common type of flash flood modeling that you see for flash flood hazard mapping, this particular option. On the left, then you see with this option enabled, so the main river system here is taken out in the left simulation, and then the example on the right is going to show a version with the primary river in this region incorporated in the simulation still. At least if it works. Jude? Oh, there we go. More like slow flood. So this is with the main river system, right? But the difference is it uses a slightly higher precipitation as a trigger for the scenario. But then it won't let it accumulate into the main river system to prevent unrealistic flow accumulation because of simultaneously applying that precipitation throughout the area. Okay, then it finished this one as well. Well, good. Oh, sorry, we have a question. Yeah, please go ahead.
Yeah, no, thanks. Sorry to stop you there. We had, I was curious to hear your thoughts or how you've considered this when we did similar work on the previous FIM project where we did kind of the equivalent of flash flood or pluvial flood for a small province, kind of province-wide across all the modeling domains and watersheds, and found during the project found out that the actual the initial conditions and antecedent conditions were having quite a big impact also on the overall behavior in terms of the pluvial, but also the combination of timings between what you were just showing now in terms of the river is coming in. So I was wondering in terms of how you might have touched this before, sorry if it's repeating, but in terms of specifically for flash floods, the initial conditions, how are you looking at it?
Sure. No, those, you're right. Those make quite a significant difference in the hydrological response, and as well in the river system. So the way we parameterize the model is we look at satellite-derived multi-year statistics of soil moisture. And then within that, we look at representative values that sort of occur not at the peaks, but during the sort of wetter season of the year as a sort of initial condition there. Mm-hmm. There is definitely some variability there in terms of if you do want to turn this into forecasting, this gives a fairly well-behaved response in terms of hazard and return period events. But then for forecasting, getting the right soil moisture in there can be quite crucial. Also there, we parameterize for forecast with the current satellite estimated soil moisture levels. But that's something that might definitely be improved with sensor data.
Okay.
Yeah, does that answer your question?
Yeah, it does. I think it's great that you're able to integrate that, the soil moisture levels, or some stats based on that. I mean, makes a lot of sense. That sounds better than how we did it at least a few years ago on that project. So.
Yeah, no, sure. If you have further question, happy to send you some writing we did about how we approach that.
Yeah.
Yeah.
Are you moving on from flash floods now? Or you have more I had another question on the stormwater infrastructure and how you're I'm sure you have some implicit assumptions on this. Are you
we have
talking
to.
about this now, or?
No, I can cover that now for you. The way we approximate the capacity of the stormwater drainage system is, well, first we sort of approximate the network based on the road network, of course. And then we sort of reverse engineer based on a global database of flood protection levels and the extreme precipitation analysis that we've done. We see, look, this city is most likely protected for this kind of return period level event. And then we see what is the actual precipitation for such an event that would fall. And based on that, we sort of specify the capacity that the stormwater drainage system would most likely have. So it's sort of moving backwards from protection level and design intensity to what capacity might likely be.
Mm-hmm. No, that sounds good. I think we did something similar, but it was more kind of using a fixed, more of a fixed service level that's assessed for the area based on kind of engineering judgment there, because we have the consultants that do a lot of work on these municipal systems too. But I think we need to consider it, because it's that data set, the global, it's a global protection something, right? That you guys are leveraging, or I forgot the full name there.
Yeah, there's a separate one we use for the larger rivers, FlowPros. There's a couple alternatives that came out in the last year, actually, that try to do it a bit more in detail.
Okay.
But we use a separate one for the urban, because the fluvial and the urban protection levels tend to be quite different. Right? In the Netherlands, for example, we do 1250 years for the Rhine near where I live, but then the city where I live, yeah, we have a stormwater drainage system that's much more in the range of 50 to 100 if we're lucky. If it's not clogged.
That's good. That's good compared to what we have here. So.
Yeah, we have sandy soil, so we're lucky there. In the city where I live, there's other cities in the Netherlands that have it a bit more tough.
Can you imagine?
I wanted to follow up on Maxim's question. Would you be able to specify a level of service if you knew what that was, right? Like, let's say, for example, we're working with a city here in Canada, and we know what the design level is for the storm system, as opposed to leveraging kind of the, assumed capacity. If we actually know what it is, could we implement it and subtract that from, let's say, the rainfall amounts, or how would that work?
Yeah, no, most certainly. You can either you can even upload your own stormwater drainage system in a bit more detail if you want, but it's definitely an option to specify the protection level, either that or the capacity of what it can handle alternatively.
Would you define outlet locations too? Like if you wanted to essentially specify where that flow would be coming back into the system?
No, at the moment, not yet. So it goes in, but at the moment, it doesn't go out. Yeah.
We're testing some. We have a few R&D projects on the go on this, and there's one where it's with the city of Montreal, and they're looking at automating the process of developing a synthetic, pipe network based on kind of open data and kind of identifying outlets automatically based on
Mhm.
DEMs and things like that. So trying to kind of start becoming closer in terms of a hybrid approach. But and there's
Yeah.
another one in Vancouver. It's another large city where they start from the catch basins. They identify all the catch basin points from image high res aerial photos or imagery, and then they just put the catch basins as outlets in the model with a representative curve, and so
Mhm.
the water exits and the catch basins, but you don't consider the. And then we have another one that was from 3 years ago that was more basic. That's the provincial one where we just take a estimated service level and subtract, the adjust the hydrology based on that. So we're kind of looking at, we have a few pots on the a fire right now, but it's a question we're very interested in. So will be great to continue the discussion.
Yeah, yeah, it's definitely an area where there's a lack of consistent large scale data availability.
Hmm.
Even often, like their municipal data is usually not openly available. You have to
Yeah,
just get the right local official to actually be able to share and be willing to spend the time to collect it. The
yeah.
formats differ widely. Yeah, that's a tricky one still.
Even the cities that have some of that have their stormwater data, pipes data, actually they never have the full city, right? So they'll be missing some neighborhoods in there, so that even those guys, they're interested in those large scale approximations that you guys are doing, the stuff we're testing too. So it's quite interesting
Mm.
that even at the municipal level, they're quite keen on trying to get that approximate level of pluvial flood hazard data.
Yeah. Oh, that is interesting. Well, yeah. Um, we'll definitely keep an eye for the projects when they finish. Are the results of those going to be public?
Yeah, yeah, yeah. It will be public. Yeah.
Awesome.
All right. Thank you.
Then for the fluvial floods, you have a bit of a choice there. If you just select an area, local area, you can disable the flash flood part, which basically turns off the local extreme precipitation and says, I'm just going to use my boundary conditions. And this is definitely a way you can use the model, right? You could have existing hydrographs or discharge forecasts from an already operational system and just use FastFlood to turn that into a detailed spatial flood map. That's the way also in which we're linking for one particular example with an existing early warning system where they already do low resolution regional modeling, but then we turn that into a detailed flood map. Yeah. So then in that case, run in any area, it's going to do the boundary conditions and turn that into the flood map for you. You can see also where the water sources are placed by the model. You can add new ones or adjust them and adjust the magnitudes. There's quite a complicated workflow to the placements of these typically. The way that work starts with this low velocity analysis data that we do a station-based AI bias correction on top of. But there's quite a resolution mismatch, of course, between that data, which is gridded at about, I want to say, 5 kilometer resolution globally, and whatever model domain the user selects. And as a matter of fact, the user has a lot of freedom to shift around and change the level of detail. So we have to have also a bit of a translation layer between this global gridded extreme flow rates and forecast for flow rates and historic ones to providing a local point-based discharge boundary condition. Now, you can see those gridded discharge extremes and the Gumbel curves that are part of that. So the return period here is on the horizontal axis, and then the discharge in cubic meters a second is on the vertical axis. And then in the platform, you can also export those. And if you want to compare those with the nearby station data, so if you click on one of the blue points, for the same river system, right? You get the same curve with uncertainty estimates as well, but then based on a nearby station. Now, so there's a little bit of translation between what you see here, just to make sure that whatever we sample from there goes into the right location exactly for the river, ends up being placed well with the right bounding condition for pressure along the inflow cross section, and then we use it. But, now for coastal, again, that you can specify your own surge and tidal combined height, and then it lets the water also inundate land inwards. There is also the automated return period based coastal bounding conditions, which are based on the Deltares reanalysis data that they ran for the Joint Research Center for tidal and surge heights where we draw from. And this is also one of the built-in options. For climate change, I'm not sure if you tried this already, but for any simulation, let me show you this in real life in the tool. Let's say we have a particular area of interest. Where have we not been yet? I feel we haven't been south. Did we? Oh no, we did some there. We haven't been here. We haven't done some Asia. So let's say we have some catchments that we're interested in. I'm just gonna select some area here. I haven't prepared this. We can just run with the default scenario if we want, although in the menu there we can include climate change as well. But let's compare between before and after. So this is gonna do the modeling, get our results to us, but then if we want to adapt that, we get the adaptation wizard with all the out-of-the-box options, and one of them is climate change forcing. Now, for each of these options, we link with some literature examples and reports that you can reference for implementation examples. And if you say configure, we can go ahead and select the climate scenario. Let's do a worst case for now for the year 2080, for example. And we can select the quantile, but I'm going to stick with the median one for now. And I say apply that, then I can rerun my simulation. And it's going to run the same scenario for the same area with all the same parameters, except that it adds the climate change scenario to it. We'll wait a little bit for that to come in. But this is quite a flood-heavy area in this tropical zone. There we go. I can compare them side by side by clicking the compare button, which takes by default your last two simulations and compares them side by side. The last one is on the left, the one before that is on the right. And we can also look at the differences, and we see quite a consistent increase in flood depths here, with up to 0.5 meter of increase for large areas. Also quite an increase in area in some spots. Going in some places even up to more than 2 meters of increase. And again, this is according to the median quantile, right? So you can redo this with the 15% and 85% quantile to also give some uncertainty range on how the climate change signal is going to impact the increase in or decrease in flooding that comes out of this. There we go. Yeah, like I mentioned, you can look at the differences there side by side and the downstream propagation of all of that. You can also see the climate trends and the analysis data from that directly within the tool by clicking right mouse button on the map and then selecting climate trends. And that opens up the specific trends for that location. They're at a 25 kilometer global grid. So those are unique data within the 25 kilometer by 25 kilometer pixel. That's a little bit about the sort of default workflows that we and types of floods we model with FastFlood. There's one that I missed, a dam break. And we do have a couple minutes left. It might be interesting to still show that very quickly. We link within in FastFlood with a global database of dams to allow for a rapid estimation of dam burst catastrophe events. The idea there is you do a custom simulation, select dam break, and you see this map globally with options. Now we use this particularly for around emergency context, right? This is not to do a very detailed study. We make plenty of approximations about the structure of the dam, the type, how it's gonna break. We draw from empirical relationships based on historical events and reference simulations to estimate peak outflow rates and the durations of the hydrograph coming out of that. But in principle, the idea is in such cases, maybe look at an example that we actually applied this in civil protection for practice, evacuation scenarios, and things like that. Here, the actual, well, there's various inputs you can use, but it fills it in automatically from the user side as well. Here, the dam's actually a bit higher than the global datasets say. And then let's pick some high quality. And select run. And this is gonna automatically put together again the parameterization of the model with the right boundary conditions for such a dam break scenario. And we can get a very, very rapid estimates of such catastrophic events. Also here, there is the option to use a sort of median quantile from the statistical output or a high or low estimate to give some uncertainty range around that and related also a little bit to the probabilities. This could have done with higher resolution. Let me do the, that's the wrong one. It's this one. I think I said, oh, sorry. Yeah, so there's a particular use case where we use this, right? Emergency context and in civil protection. There's some advanced options around also simultaneous having a rainfall event, etc. For now, I'll try to do a bit higher detail modeling and show that output to you. 40 meter might be a bit much for such a large area, but we'll see if it likes that. And then also with sort of scenario exploration, but it is not particularly meant to do a very detailed site investigation. In principle, the model, the flood model, should be capable of providing just as good results as any other flood model might do. But then we don't particularly focus in very high detail on the dam's engineering aspects. Yeah, so that's the short overview of the different types of models that we run. Are there any questions on this?